So we continue with our calculus as we look at some more practice questions for finding equations of the normal and also evaluating and also finding the equation of the curve when they have given you that. So how can we go about that? So let's try to look at some solutions to these questions. Make sure that you practice. Practice makes you improve. As they say, practice makes you perfect. Yeah, it actually makes you improve. The more you practice, the more you become acquainted with what we're doing. So it says find the equation of the normal to the curve. So they have given you the curve y is equal to 5x raised to the power 3 minus 6x squared plus 2x plus 5. That's what they have given us. So they want us to find the equation of the normal. So you remember some concept at the point. So that point is very important at the point 1, 2. It's good they have given you both the x and the y value. Sometimes they can just give you one value. You need to find the value of y by replacing this into that expression. So the first thing, you find dy over dx, you differentiate. So when I differentiate this times that would be 15, then that would be x, that power reduces by 1, minus that would be this times that is a 12, x the power reduces by 1, I'll just leave it. Then 2x, when I differentiate that, I'll have a 2. The last one there, I'll have a 0. So therefore, this is just going to be 15x squared minus 12x, plus 2. That is what we mean. So that is, what we are going to have there. So now, what are we going to do next when we find that? Well, it's very simple. When we find that, we need now to find the actual gradient. Remember, how do we find the actual gradient? They have given us dy over dx. But when my x, they have given us those points at the point 1, 2. So this is the value of x, that is the value of y. So when x is what? Is 1. So we replace in that expression that we are having there when our x, so that we know the actual gradient at that point. So it will be 15 multiplied by 1 raised to the power 2 minus 12 times 1 plus 2. So that would be just 15. 1 raised to the power 2 is 1 times 15, 15. That would be 12 plus 2. So if you were to 15 minus 12 plus 2, you can still follow your board mass, very important. It will give us a 5. So meaning that when x is 1, the gradient is simply, when x is 1, the gradient is simply 5. So this gradient that you get, the moment the gradient you get is simply the gradient of the tangent, which is equal to 5. But our interest is finding the equation of the normal. So we have to find the gradient of the normal. So how do you get the gradient of the normal? Remember we said the gradient of the normal is simply -1 divided by the gradient of the tangent. So it will be -1 over 5. So -1 over 5 is the gradient of the normal. So now I can find the equation because I know the gradient of the normal is -1 over 5. Then you use these coordinates they gave you, which is 1, 2 to find the equation. So we first of all need to find the y-intercept. Y is equal to mx plus c, the equation of a straight line. So we can now, replace to find the y-intercept c. So that is x and that is y. So what is my y? It is simply 2 is equal to the gradient, -1 over 5, multiplied by your x, which is a 2, plus your c there. That's what we mean. So it is going to be 2 is equal to, this times that will give us -2 over 5 plus c. This will go the other side. It will be 2 plus 2 over 5 is equal to c. Therefore, you can just put that one on your calculator. So how is that going to be? 2 plus 2 over 5. That is going to give you 12 over 5. So that is your y-intercept. Now, once you find your y-intercept, you can now say, once you find the y-intercept, we can now say, equation. So we can now say equation of normal. The equation of the normal will be y. You replace your gradient and your y-intercept. The gradient is -1 over 5x. And what is my y-intercept? It is 12 over 5. you can simply end there. Others can still multiply, but they can say over 1 and multiply the whole thing by the common denominator, which is a 5. It can give them 5y is equal to negative x plus 12. It's possible, you can leave it that way, or 5y, this can come plus x is equal to 12. If you are not so comfortable with this, please just end there. That is okay. That is the equation of the normal. That's what I wanted you to do. All right, let's move on to the B part there. The B part there says we evaluate. So number 1B says we evaluate. Remember what we looked at when they give you the upper and the lower limit, 3x squared, plus 4x with respect to dx. So how is that going to be? To be 3x squared plus 1 divided by the new power, which is a 3 plus 4, that is 1 plus 1 divided by the new power, which is a 2. Of course, whatever we have, the upper limit 1 and 3. So we can reduce that. It will be x raised to the power 3 plus 2 there, 1, 2 there is a 2. So we are going to have 2x raised to the power 2. So this is what we have, and we include the limits. So we can replace the upper limit minus the lower limit. So the upper limit, when we replace, it is going to be 3 raised to the power 3 plus 2 multiplied by 3 raised to the power 2 minus what we replace from the lower limit. So it will be 1 raised to the power 3 plus 2 multiplied by 1 raised to the power 2. So that's what. So that will be 27 plus 3 raised to the power 2 is 9. 9 times 2 is 18. So this is what we are having there, minus. So 1 raised to the power 3 is 1 plus 1 raised to the power 2 is 1 times 2. That will give us a 2. So what is 27 plus 18? So that is going to give you a 45 minus a 3. 45 minus 3, well, that will give us a 42. So that is what they wanted us to do there. So it's not complicated, it's very simple, and you'll be finding those questions as carrying 3 marks, some of them. It's easy for you to work them out. Let's go to question number 2. We give you some more concept now. So this is slightly different. The question that came, all these came in the ECZ exam, so you need to practice. So this question is slightly different. I want you to pay attention on 2A. It says the gradient function. So they have given you the gradient function of a curve is that. In other words, what they mean is that dy over dx is equal to 6x plus 8. That's what they mean when they say the gradient function of the curve is that. Then they tell you find the equation of the curve. So they want you now to find the actual equation of the curve. That's what they want you to do. But passing through the point 1, 1, 2. Okay, so they have given us that point, which is actually very good. So passing through the point 1, 2. So now we need to go back to the actual equation because we want to find the equation of the curve. So what was the actual equation of the curve, but when it is passing through this point? So meaning, for you to know the value of y, the actual equation, the actual function that they had, y, you need to integrate your dy over dx. So your dy over dx in this case with respect to x. But of course, what are we going to do? Don't worry, we'll show you. So y is equal to, so we integrate. In this case, what do we integrate? 6x plus 8 with respect to x. So what will that give us in this case when we integrate? So remember, it will be 6x, that is plus 1 divided by the new power, which is 2 plus 8. When you have a number, you just give a number and a letter, so it will be 8x. But remember, because you don't have the upper and the lower limit, you need to put up the arbitrary constant. We can now try to reduce 2 there, 1, 2 there is a 3. So it will be y is equal to 3x raised to the power 2 plus 8x plus c. Okay, so now we have this one. So it's taking us at least, to something, the equation of the curve. So we need to find that c. So how do I find that c? Well, to find that c, they told you that it is passing through the point 1, 2. So we are going to use this point and replace them there so that we can know C. Once we know C, that will give us the equation of the curve. So how is that going to be? Remember, my y is simply a 2 is equal to 3, 1 raised to the power 2 plus 8 multiplied by 1 plus C. So it will be 2 is equal to 1 raised to the power 2 is 1 times 3 is a 3 plus 1 times 8 is 8 plus C. So it will be 2 is equal to this plus that. That will give us 11 plus C. The 11 will cross the equal sign. It will be 2 minus 11 is equal to C. So what is that going to give us? Negative 9 is equal to C. So now it simply means that, when we find the C, the equation of the curve, therefore the equation of a curve will be y is equal to 3x squared plus 8x. And what is our C? Remember, it is a negative there. That's what we have. So if that is a negative 9, negative and positive will give you negative. So it will be minus 9. So this is it was the equation of the curve. And it's true, if you were to find the gradient function of this one, notice the gradient function. If you had the line y is equal to 3x squared plus 8x minus 9, you are to find dy over dx. To be this times that would be 6x, and that one will just give you 8. And this is what they gave us there. A constant is just a 0, so you can just ignore it. So basically that is the way you can actually treat that. Let's look at the B part. Let's try to look at the B part and see how we need to do that. Remember, I talked about the chain rule when differentiating. So the B part now in this ECZ question required you to apply that to B. So find the equation of the tangent. So they want us to find the equation of the tangent to the curve. What's the curve? The curve is y is equal to 2x plus 3 raised to the power 3 at the point, remember, where x is equal to 1. Now when x is equal to 1, if you don't want, right away you can know what is y by just replacing there. Let's just try to find out what y is. It will be 2 multiplied by 1 plus 3, whatever we are getting, raised to the power 3. So this times that is a 2 plus a 3 raised to the power 3. So that will be 5 raised to the power 3. That will give us a 125. So in other words, when x is 1, y is simply 125. So let's keep that value. Let's keep that value. Y is equal to 125. We'll use it at some point maybe. All right. But of course, it may not actually be applicable, but you are going to see that it will be applied. So what do? We simply differentiate that. This is where we said you can say, or this guy inside can be represented by u. So we can say let u be equal to what is inside, 2x plus 3. Remember, using the chain rule, it means that y will be equal to u because this raised to the power 3. So I'm using the chain rule to differentiate this one. So now we need to differentiate dy over du, which is going to be 3u to the power 2. We also do the same for this one. We differentiate du over with respect to x, so that will just give me a 2. So remember, to get dy over dx, it's like we are saying dy over du multiplied by du over dx. But like I said, this doesn't mean it cancels. No, you're finding the derivative. So what is dy over du? It is 3u raised to the power 2 times a 2. This times that will give you 6u raised to the power 2. We can go further and replace what our u is because we know it is that. So it is 2x plus 3 raised to the power 2. So that is our dy over dx there. So this is what they wanted us to get there. So once we get that, remember, we want to find, I'll clear that because I've already used that one. We want to find the equation of the tangent. So we need to know now the gradient. We need to know the gradient. So how do I get the gradient? So remember, dy over dx. But of course, we know our x is, when x is equal to 1, what is the gradient? So it will be 6, 2x plus 3 raised to the power 2. So 6 to be 2 times 1 plus 3 raised to the power 2. That would be 6. This time that is 2 plus that is 5. 5 raised to the power, so that is 5 raised to the power 2. So 6, the 5 raised to the power 2 is 25. So that is going to be 6 times 20 times 25. So that is going to give us 100 and what? That is going to give us 150. So that is what we are going to have. So that is our gradient that we are having. Well, that seems to be a very, very big value that we do have. All right. And that is what the question gave us. So now the next step that we are going to do is simply to find the gradient. So let me just do it from the top there. To find the equation of the tangent. So the gradient, so what we have found there is simply the gradient of the tangent, which is a 150 there. So now when you find the gradient of the tangent, now the equation will be y is equal to mx plus c. So you know the gradient of the tangent is a 150. Then remember the coordinates we have there, x is 1, y is a 120, a 125. So this is x and y. So we replace, that will be 125 is equal to the gradient is a 150 times 1 plus our c. We want to find our c. So it will be 125 is equal to 150 plus c. When this goes that side, it will be 125 minus 150 is equal to c. So that is what we are going to have there. The next thing we know, of course, that will give us a 125 is equal to c. Therefore, I can simply say equation of tangent, the equation of the tangent will be y is equal to, what's our gradient? It's 150, remember, 150x, and what's our c? 120 plus 125. So this is what they wanted us to do. So just a quick recap, you need to find the derivative of that. You can use the chain rule in that case. So use the chain rule to find that, so that it's easy, because if you want, you can expand it up to 3 times. It's okay with you if that's okay, but the easiest is by using what we are calling as being the chain rule, and try to replace. Thank you so much for watching. See you in my next practice video.